So hello everyone, this is Farid Rahimi. I would like to continue our laboratory of Python programming for air pollution engineering. So in this assignment, I would like to introduce uh, functions, numpy, and matplotlib library manipulations. So for that, I prepared a list of exercises. So we have had exercise from exercise 1 to exercise 11. So what I would like to correct with you is the exercises 1, 2, 3, 4, and 5, and I will leave for you from 6 to 11. So it would be uploaded on the Blackboard. So you should upload your work next week by the end of the next week. And for me now, I would try to start with you working on these exercises. So what I did, I made almost, you have a lot of similarity. Uh, After seeing the exercises from 1 to 5, normally you should be able to do the others. Okay, so let's start. So I started with exercise 1. I took a screenshot. I put it here. So I added the link. So with the width and the height. This is my image of the first exercise. So this is my first exercise, and the aim of this first exercise is to create two functions. So the aim here is mainly how to create a function. So we will create a first function called Cartesian to cylindrical. So this function will permit, if you inject XYZ coordinates of any point M in the space, you are able to get rho, theta, and Z, which are the cylindrical coordinates. So for that, I would do the following. I would start by working. So if if I look to this, so this is the coordinate of the points in Cartesian. If you have an entry in cylindrical coordinates, and for this, so this is an indication, and these are the coordinates of the points, rho, theta, and z in cylindrical coordinates. If you have an input in Cartesian, so if I would create a function Cartesian to cylindrical, I will say that. So mainly, if it is better for in such situation to import the library numpy as np. Okay, so I will define a function, define, and this function will have this same name. So since here you have CAR T2 and C capital YL, and you should keep the same syntax or same notation for the capital and for the small letters. So the inputs will be X, Y, and Z. Okay, so here, sorry, point. So here, I would like that rho is equal to NP dot and I can use the function sqrt, okay, or I can do it in different ways. It's up to you. So this is how I'm approaching the thing. So sqrt, and here x exponent 2 plus y exponent 2. So this is for rho. For theta, I'm gonna write it like this: theta or theta, it's up to you. So it's np, np dot arctangent. So arctangent, this one, okay, arctangent of y divided by x, and maybe there are some particular cases when x equal to 0. So for that, I will add a very small value here, because sometimes you will have an error. If x is equal to 0 here, you will have you have a problem of division. So for that, maybe I would add x, uh, or maybe I'm gonna keep it like this, and we're gonna later on, I will show later on how to treat these particular cases, because you need to add exceptions for this. And for z, you will keep it equal to z. So for that, at the end, you have to return, okay, you have to return what? Rho, theta, and the z is the same. Yani, we can at least remove this from here, since it's not mandatory. There's no need to. Uh, you can keep it like this. Okay, you can keep it like this. You need only to calculate rho and theta. So this is how to calculate the cylindrical coordinates of a point. So now, if you would like, so this is my first function. If I would like to define the inverse function, which is uh, from cylindrical to Cartesian to Cartesian, so it have also an input, in this case, rho and theta. By the way, I'm not in the obligation to write rho. I can write r, and just because if I would like to write r, or maybe I can write rho like this. It's not mandatory. Or theta, I can write it like this. Theta in this case, because they are completely separate. Here, this is my first function. This is my second function. So here I will have x equal to rho cross np dot cosine theta. Okay, and for y it's the same. The only difference is that you will write that y is equal to np sine theta. And like this, you don't forget to return x and y. I'm not in the obligation to write in the x and y. I can write x1, y1. These are local variables, and you can have x and y in your program. In your program. So like this, I finished my the calculation of this. I can apply this, by the way. I can, for example, if imagine row one. So imagine I'm gonna use this row one, theta one is equal to, and imagine I'm gonna inject. This is my function. I'm gonna inject x equal to 20 and y equal to 20, and I can print so row equal to, and theta equal to dot format. Here I'm writing row one, or I can call it like this, row one and theta one. Okay, so it's up to you to give the correct names. Now, if you run this, okay, you have the following. So this is the distance, okay, and by the way, you can verify this, because in reality, what happens when you calculate, so this is for the rho and the theta, and you can verify the value of rho, which is the calculated this way, okay? And for the theta, which is given by the arctangent. As I said, there is a particular case where x equal to 0. You should add an exception for this. We're gonna come back to this later on. So this is how to run your script. Here x equal to 20, y equal to 20, and z is equal to z if you are in now the opposite. By the way, if you take the same values, these values, and you try to apply them for the inverse function, certainly you will find a slight difference of rounding. So if I take this second function from cylindrical coordinates, okay, to Cartesian, and I take this same row just to verify, maybe I'm not 21 point. I'm not in the obligation to take all this value. I'm going to take only like this, okay? And for the theta, I'm going to take it, and here I'm going to put 4. Okay, so here instead of 3, I'm going to put 4. So now I have x, y from cylinder. This is the row, and this is your theta in radian. So now this is your x, this is your y, okay, and here these are the values of x and y. Run again. So as you see, here I have 20.1. It's simply because I don't took all the value. And here is the second value. If you take the total values like this, you will have something at maximum near the result you are searching for. Maybe you can, if you take it completely like this, okay, and you run it again, you have 20, and this is the error of a float number. So it's equal to 20. So this is for the first exercise.